Construction columns are vertical structural elements designed to transfer loads from the structure above to the foundation below. They come in various types depending on the material used, the purpose, and the design. Here's a breakdown of the main types of construction columns. 1. Based on material. A. Concrete columns. Reinforced cement concrete, RCC, columns, most common in modern buildings, reinforced with steel bars. Plain cement concrete, PCC, columns, used where loads are light, no reinforcement. B. Steel columns. Made using rolled steel sections, I-section, H-section, etc. Common in industrial and high-rise buildings due to high strength and flexibility. C. Timber columns. Used in traditional and residential construction. Often seen in heritage or rural structures. D. Composite columns. Combine materials, e.g., concrete filled with steel tubing, for better strength and performance. Used in high-load structures and modern architecture. E. Brick or masonry columns. Built using bricks or stones with mortar. Common in load-bearing masonry walls. 2. Based on shape or cross-section. Rectangular or square column, common in residential and commercial buildings. Circular column, often used in aesthetic or architectural designs, also good for withstanding loads from any direction. L-shape, T-shape, or Y-shape columns, custom shapes used for architectural or structural needs. Octagonal or polygonal columns, decorative, sometimes used in temples or monumental structures. 3. Based on structural use. Axially loaded column, load applied along the central axis, uniform compression. Eccentrically loaded column, load is off-center, causes bending in addition to compression. Short column, height is less compared to its cross-section, fails by crushing. Long/slender column, tall relative to cross-section, prone to buckling. 4. Based on construction method. Cast in situ columns, poured and cured on-site with formwork. Precast columns. Manufactured off-site and assembled on-site. Pre-stressed columns, contain pre-tensioned or post-tensioned steel to resist tension. 5. Based on load carrying capacity. Compression column, carries compressive load. Tension column, rare, but designed to carry tension, e.g., in suspension bridges or certain cantilever structures. Combined load column, subjected to both axial and lateral, bending, loads. If you're designing or analyzing a building, the material, load type, and aesthetic or functional purpose will influence the type of column you choose. Let me know if you need diagrams or recommendations for specific applications. Concrete columns are vertical structural elements that play a critical role in transferring loads from the upper parts of a structure, such as floors and roofs, down to the foundation. They are essential in both residential and commercial construction and are commonly found in buildings, bridges, parking garages, and other infrastructure projects. Types of concrete columns. Concrete columns can be classified based on their shape, function, or method of construction. Based on shape. Rectangular or square columns, common in residential and commercial buildings. Circular columns, often used in parking structures, bridges, and aesthetic designs. L-shaped or T-shaped columns, used when the column needs to integrate with walls or other architectural features. Based on function. Axially loaded columns, subjected to vertical loads only. Eccentrically loaded columns, subjected to both vertical loads and bending moments. Columns with lateral loads. Designed to resist horizontal forces such as wind or seismic activity. Based on construction method. Cast-in-place concrete columns, poured and formed on the construction site. Precast concrete columns, manufactured off-site and transported to the construction location. Pre-stressed concrete columns, reinforced with high-strength steel tendons to improve performance under stress. Components of concrete columns. Concrete provides compressive strength and durability. Reinforcement bars, rebar steel bars embedded in the concrete to provide tensile strength and resist cracking. Formwork, temporary molds used to shape and support the concrete until it hardens. Stirrups or ties, horizontal reinforcement that holds the vertical rebars in position and resists shear forces. Design considerations. Designing a concrete column involves accounting for load-bearing capacity, slenderness ratio, the ratio of height to the least lateral dimension, column length and effective length, material properties, concrete grade and steel reinforcement type, building codes and safety factors. Advantages of concrete columns: high compressive strength, fire and corrosion resistance, low maintenance, long service life. Challenges: heavier than steel alternatives, takes time to cure, in case of cast in place, potential for cracking if not properly reinforced or cured. In summary, concrete columns are fundamental elements in structural engineering, valued for their strength, versatility, and reliability. Proper design and construction practices are crucial to ensure their safety and effectiveness in supporting structural loads. Steel columns, overview and importance. Steel columns are vertical structural elements used in construction to support loads primarily through compression. They play a vital role in buildings, bridges, towers, and other structures, providing strength, stability, and support to transfer the load from the upper parts of the structure down to the foundation. Types of steel columns. Steel columns come in several shapes and configurations, depending on their intended use and the load they need to support. Common types include H-shaped or I-beam columns, strong in both directions, commonly used in high-rise buildings and commercial structures. Box columns, hollow structural sections, HSS. Square or rectangular tubes, aesthetically clean and resistant to torsion, twisting forces. Circular columns, CHS, circular hollow sections. Round steel tubes, often used in architectural applications or where wind resistance is important. L-shaped and T-shaped columns, used in specific design requirements, often as part of composite structures. Materials and grades. Steel columns are made from various grades of structural steel, which differ in strength, ductility, and resistance to environmental factors. Common grades include ASTM A36, standard carbon steel. ASTM A992, high-strength steel for wide flange shapes. EN 10025S355, European standard for structural steel. Design considerations. When designing steel columns, engineers consider factors such as load capacity, dead loads, permanent/static, and live loads, temporary/moving. Buckling resistance. Tall, slender columns are prone to buckling under axial loads. Connection details. How the column joins with beams, slabs, and other elements. Fire resistance. Steel weakens at high temperatures, so fireproofing may be needed. Corrosion protection. Coatings or galvanization may be applied for durability. Advantages of steel columns. High strength-to-weight ratio, strong yet relatively lightweight. Speed of construction. Prefabricated sections allow for faster assembly. Flexibility in design, easy to adapt to architectural requirements. Recyclability. Steel is 100% recyclable, supporting sustainable construction. Applications. Steel columns are widely used in commercial and industrial buildings, warehouses, malls, factories. High-rise buildings, where strong yet slender support is required. Infrastructure projects, bridges, towers, and stadiums. Residential buildings, especially in modern designs with open floor plans. Conclusion. Steel columns are a cornerstone of modern structural engineering, providing reliable support for a vast range of buildings and infrastructure. Their strength, versatility, and adaptability make them a preferred choice in many architectural and engineering applications. Proper design, material selection, and protective measures ensure their long-term performance and safety. Timber column. A timber column is a vertical structural element made of wood, designed to support loads from above such as beams, slabs, or other structural components. Timber columns are commonly used in traditional wooden construction as well as in modern timber-framed buildings. Characteristics of timber columns. Material. Timber columns can be made from solid wood, such as oak, pine, or cedar, engineered wood, like glued laminated timber or glulam, or composite wood products, such as laminated veneer lumber or LVL. Load-bearing. Timber columns are primarily used for their compressive strength. They carry axial loads and may also resist lateral or bending forces, depending on their placement and connection. Shape and size. Rectangular or square, common in residential and light frame construction. Round, often used for aesthetic purposes or in log structures. Custom profiles. In architectural designs, timber columns may be carved or shaped for visual appeal. Connection methods. Timber columns are connected to other elements using mechanical fasteners like bolts, dowels, steel plates, or mortise and tenon joinery. Modern construction may also use metal brackets or concealed connectors. Types of timber columns. Solid timber columns, made from a single piece of timber. These are strong and traditional but may be prone to warping or splitting over time. Glulam columns, built from layers of timber glued together. They offer improved strength, dimensional stability, and can be manufactured in larger sizes. Composite timber columns, made using a combination of wood products and adhesives to enhance strength and durability. Advantages. Aesthetics, warm, natural appearance that enhances the visual appeal of a space. Sustainability, wood is a renewable material and has a lower carbon footprint compared to steel or concrete. Workability, easy to shape, cut, and join, making timber ideal for custom construction. Insulation, wood has natural insulating properties. Limitations. Moisture sensitivity, timber can swell, shrink, or rot if not properly treated or maintained. Fire resistance, although large timber members char slowly and can retain strength, untreated wood is still combustible. Insects and decay, requires treatment to resist termites, fungi, and other biological agents. Applications. Residential construction, timber columns are widely used in framing houses, porches, and decks. Post and beam structures serve as the primary vertical support in many traditional and modern architectural designs. Restoration projects, often used in the preservation or reconstruction of historic buildings. Interior design, decorative columns made from timber are used in lobbies, living rooms, and commercial interiors.